Voyager 1 and 2 their mission to explore the outer planets, and then keep going. Keep drifting into the darkness. What they captured out there, billions of miles from Earth, in the cold emptiness of space, scientists still can't fully explain. This is actual sound, recorded from deep space. And what you just heard, that's only the beginning. Stay with me, because the last sound in this video will absolutely give you chills. Sounds that most people have never experienced. You'll understand the science behind these mysterious transmissions, how they're captured, what they really are, and why they exist in the first place. But more importantly, you'll discover why some of these sounds still puzzle even the brightest minds at NASA, the European Space Agency, and space research centers around the world. These aren't just interesting noises, they're mysteries, cosmic enigmas that challenge everything we think we know about the universe. Let's dive in. Now, before we get to the sounds themselves, we need to address something that confuses a lot of people. Wait a second, sound in space. But isn't space a vacuum? Exactly. You're absolutely right to be skeptical. Here's the thing, space is a vacuum. There's no air, no atmosphere, no medium for sound waves to travel through. If you screamed in space, nobody would hear you, not even you. So how can we possibly hear sounds from space? Well, we can't, not directly. What NASA's spacecraft actually detect are electromagnetic waves, plasma vibrations, and radio emissions. These are invisible forces pulsing through the cosmos. The spacecraft pick them up with specialized instruments. Then, scientists do something fascinating. They convert these frequencies into audio waves that our human ears can actually process and hear. Think of it like translation, like turning light into sound. The data is real. The phenomenon is real. We're just transforming it into a language our ears can understand. So when you hear these sounds in a moment, remember, you're listening to the universe speaking, just translated into human terms. So let's talk about the machines that made these discoveries possible. The Voyager probes. Launched in 1977, these two spacecraft are humanity's most distant ambassadors. Right now, as I'm speaking to you, Voyager 1 is over 15 billion miles away from Earth. That's billion with a B, and here's what's incredible. It's still sending data back home. After almost 50 years in space, traveling through the harshest environment imaginable, these machines are still talking to us. Then there's Cassini. This spacecraft spent 13 years orbiting Saturn, studying its rings, its moons, its storms. It sent back some of the most breathtaking images we've ever seen of another planet. Now, here's the key thing to understand. These spacecraft weren't designed to record sounds as you and I would think of them. They're not flying around with microphones attached, but they have magnetometers, plasma wave detectors, radio receivers, instruments designed to measure invisible forces in space. And these instruments, they picked up something extraordinary anyway: vibrations, emissions, waves of energy pulsing through planetary magnetospheres and the fabric of space itself. Scientists took that raw data and transformed it into audio, and what emerged was nothing short of haunting. So now that you understand how this works, let me take you on a journey. We're going to listen to 4 sounds from deep space, each one stranger than the last. Starting with the largest planet in our solar system, Jupiter the Giant. A planet so massive you could fit over 1,000 Earths inside it, and it has a voice. Close your eyes for a moment. Just listen to this. Jupiter sounds like something straight out of a science fiction horror film, doesn't it? Like the soundtrack to an alien invasion. Eerie, unsettling, almost alive. But this is not Hollywood. This is not a sound designer creating atmosphere for a movie. This is real, 100% real audio data from Jupiter's magnetosphere. So what exactly are you hearing? Jupiter has one of the most powerful magnetic fields in our entire solar system. It's absolutely massive, and this magnetic field accelerates charged particles, electrons and ions, to incredible speeds. As these particles spiral through Jupiter's magnetosphere, they create radio emissions, waves of electromagnetic energy that pulse outward into space. When scientists convert those radio waves into audio frequencies we can hear, this is what emerges: these whistles, these shrieks, these strange, rhythmic pulses. But here's where it gets really interesting. The patterns change. They shift in ways scientists didn't predict. Sometimes the emissions intensify. Sometimes they fade. Sometimes entirely new patterns appear that we've never documented before. We know what causes the base phenomenon: the magnetic field, the particles, the physics. But why the variations? Why these specific patterns? We're still figuring that out. Jupiter's atmosphere is a churning chaos of storms larger than our entire planet. Perhaps those influence the magnetic field in ways we don't fully understand yet. Or perhaps there's something else happening, something we haven't discovered. Now let's travel to Saturn. Saturn has a secret. At its north pole, there's a storm. But this isn't just any storm. It's a perfect hexagon. I'm not exaggerating. It's literally a six-sided geometric shape spinning at Saturn's pole. The edges are sharp. The angles are precise. It looks almost artificial, and it has a soundtrack. Listen. That's the sound of plasma waves rippling through Saturn's atmosphere, captured by the Cassini spacecraft as it flew past this bizarre storm system. Now, let me give you some perspective on the scale here. This hexagon is bigger than two Earths placed side by side. The storm itself has been raging for decades, probably much longer. We've been watching it since the Voyager probes first spotted it in the 1980s. But here's the question that haunts planetary scientists. Why is it a hexagon? Storms on Earth are circular. Hurricane, typhoon, cyclone. They spin in roughly circular patterns because of the Coriolis effect and atmospheric dynamics. But Saturn decided to create a perfect six-sided polygon. And it stays that way, year after year, decade after decade. We have theories: atmospheric wave patterns, standing waves created by wind speeds at different latitudes. Fluid dynamics we're only beginning to model accurately, but the complete physics, the exact mechanism that creates and maintains this impossibly perfect shape, we still don't fully understand it. And that sound you just heard is the voice of one of the greatest geometric mysteries in our solar system. August 25th, 2012. On that day, Voyager 1 did something no human-made object had ever done in the history of our species. It left our solar system. For 35 years, Voyager had been traveling through what we call the heliosphere. That's the bubble of charged particles constantly streaming out from our sun, the sun's influence, the sun's domain. But on that day, Voyager crossed the heliopause, the boundary, the edge. It entered interstellar space, the space between the stars, and it recorded this silence, interrupted by faint vibrations, the hum of cosmic rays, the whisper of the interstellar medium. This is the sound of the place between star systems, the vast emptiness that separates our sun from the next closest star, over 4 light-years away. The density of particles out there is incredibly low, almost nothing. Just a few atoms per cubic centimeter, drifting in the void. And you can hear the difference. When Voyager was still inside our solar system, the plasma waves were more active, more energetic. But out there, beyond the edge, everything becomes quieter, more sparse, more lonely. Think about this for a moment. You are listening to a sound from a place that no human being will reach in our lifetimes. Not in this century, probably not in the next. It would take tens of thousands of years for us to travel there, even with our fastest rockets. This is the most distant sound ever captured by humanity. The universe's heartbeat, recorded at the edge of everything we've ever known. Now, this last one is different. With the previous sounds, we had explanations. We understood the source, even if some details remained mysterious. But this one, scientists have theories, they have hypotheses, they have educated guesses, but no definitive answer. Listen carefully. What you just heard was captured in deep space by one of our monitoring spacecraft. The exact location and mission details have been debated in scientific circles for years. Some researchers believe it could be the result of plasma interactions we've never documented before, waves colliding in ways our models didn't predict. Others think it might be electromagnetic interference from a previously unknown source. Perhaps a phenomenon we simply haven't encountered enough times to categorize properly. There are even more exotic theories: interactions with dark matter, quantum fluctuations in the fabric of space itself. But here's the honest truth: we don't know. We have the data. We have the recording. We've analyzed it dozens of times with the best equipment and the brightest minds on the planet. And we still can't say with certainty what created this sound. That's what makes space both terrifying and beautiful. There's still so much out there we don't understand. So many mysteries waiting in the darkness. And maybe that's exactly as it should be. These sounds remind us of something important. The universe is not silent. It's humming, crackling, singing in frequencies we're only beginning to understand. Every strange noise, every unexplained pattern, every mysterious transmission is a clue, a piece of a cosmic puzzle that spans billions of light years and billions of years of time. And maybe that's the real point here. Space doesn't give us easy answers. It never has. It probably never will. What it gives us are mysteries, questions that push us to explore further, to build better instruments, to think harder, to wonder more deeply. These sounds aren't just audio files in a NASA archive. They're invitations to be curious, to ask why, to venture into the unknown even when we're not sure what we'll find. Because that's what separates us from every other species on this planet. We hear something strange, something unexplained, something that doesn't fit our models. And instead of ignoring it, we lean in closer. We listen, we investigate, we try to understand. And in that process, we discover things about the universe and about ourselves. So which sound disturbed you the most? Was it Jupiter's eerie screams, Saturn's geometric mystery, the loneliness of interstellar space, or that final unexplained transmission? Drop a comment below. I genuinely want to know. And if you're hungry for more space mysteries like this, I've got more videos coming. Deep dives into cosmic phenomena that will blow your mind. Hit that subscribe button so you don't miss them. And if you enjoyed this journey to the edge of our solar system and beyond, leave a like. It genuinely helps more people discover these incredible sounds and the mysteries they represent. Thanks for listening to The Universe with me.